So in the numerical system, the first way we had representing numbers in marketing was with hash marks, tally marks. So about 4,000 or 5,000 years ago, the Egyptians had their first systems. They exactly had the base 10. What does base 10 mean? You ever heard of base systems? We have a base 10 system. But think about it. From 0 to 9 is how many numbers? And then we go to 10 to 19. Then 20 to 29. So the only thing changes now is the first number. Until we get to 90 to 99. What happens? Oops. I'm sorry. Then what happens after that? Yeah, because now after 9 comes 0 and add one more to it. This one, add 1 to it, becomes 0, carries a 1. So there we have from 100 to 199. So this is what we're looking at here. And so we're looking at, these are all base 10 systems. That's why we go from 0 to 100. We go from, actually 0 to 99. Then from 100 to 999. And again, each inside those is how many numbers between here? Which is 10 times 10. We have 2 zeros, so therefore we have 2 tens. If we had 4 zeros, how many tens do we have? So it all breaks down neatly that way. So that's what Egyptians, without realizing it, that's what they created. So after they had the first 9, from 0 to 9, they used the heel bone. It's not the end like we have here. It was actually a heel bone. Then they go to a scroll, lotus flower, pointing finger. So this is pretty cool how they did this. So now, in order for these things to work, for example, if you had this number here, if all these symbols here were written, how would we get this number? Add. So they had to have created a mathematics system back then, an addition system. What time you think of it, that's pretty big steps. Because if you have addition, that means things are getting bigger. What about when you take things away? Even though it's not represented here, they also used a subtraction system without knowing it. So think about it. This is back when they didn't even have, well, they had papyrus back then, but this is pretty interesting. Way, way, way back then, they created math to be able to exist and have commerce. So we had 3 of these scrolls. Each scroll is 100, so that's 300. 2 heel bones, that's 10 each. 2 staffs, and 1 pollywog or bird bot. So that's where they created that addition system. Pretty interesting. Now, you think that was done universally? Because remember, back then Egypt was the ruling party. What other civilizations were around back then? Where is Egypt? Africa. It's in the eastern side of Africa. But what about the rest of the world? Yeah, even closer to Africa, but where Iraq, Iran, Turkey, where all the countries are, which is not too far from there, which is even closer. Yeah, Europe also, but Europe back then was still in the not even the medieval. It was primeval back then because there were still clans of people who just were fighting and just trying to get more land. But then you also have like the Asian countries, which we know little about because nobody really studied them back then, and they kept all the history to themselves. But China and Japan, which would those areas now, and India, though they were much further ahead than we expect. I mean, China had drilling uh, drilling heads. So if you're drilling straight down for water, if you hit a rock, you can drill through the rock. The rest of the world, if you're drilling down to get water and you hit a rock, you have to try another hole somewhere else. So it wasn't until Howard Hughes came up and invented the diamond head drilling bit to go through rock to get oil. But China had this already thousands of years ago. So that's if you want to study, I would like to study history of Asia to see exactly how far they were ahead with math, sciences, the astronomy, physics. Okay, the next one we're going to look at the Babylonian system. Babylon. They used the stylus. What's a stylus? Well, we use a stylus now to write on iPads but back then a stylus it was a writing instrument where you wrote on clay tablets. And theirs is pretty basic so far. You only needed a symbol for one. Once you got to 10, again, it's interesting why do you think at number 10 they jumped to another symbol? Why do you think that is? Yeah, but what made them use 10 as the stopping point? Why not 8? No. It's actually it's a great question. Good ideas though, but think about what's at the end of your hands. We have to, and that's where they can count. So was all the world the same? They couldn't use their toes. Well, some countries could use their toes. The warmer climates, like the islands or the people in the coastal regions. But the rest of the world in Europe and stuff, they only use their hands because they had to cover their feet to not freeze to death. So that's the reason 10 is the magic number. The Babylonians now had a place value system. What does a place value system mean? What the place value system does, it assigns a value to the digits depending on where it's placed. Do we do the same thing? Yeah, because in our system, we don't read that as 135. We read that as what? Yeah. 135. Why is it read that way? Why is it 100, not 531? Yeah, we read it. That's right, exactly. And that all started because when the Egyptians, they wrote their numbers when there was horizontally, there was left or right. But if you think about it, we really have to look at this from right to left because we have a base 10 system, which I'll get to later on. What number is this? It's the what number column? The ones. What number is this? What number is this? Well, it's base 10. So it's 10 to the 0 equals 1. 10 to the first equals 10. 10 to the second equals 100. So this is going backwards. We start off here, then we go in. So we read it left to right, but we write it from right to left. We build our numbers from right to left. It goes from 0 to 9, and then we add a number to the left. To 99, then we add another number to the left. The number grows to the left, and we read it right to left, which is, it's always baffled me. So let's look at these examples here. So the Babylonian numerals 1 through 59 are similar to Egyptians, but the vertical staff and heel bone were replaced by other symbols. The difficulty with having like the Egyptian is you have to memorize what all those meant, along with all the other hieroglyphic symbols. So actually, if you ask me, that was pretty complicated systems. This one's pretty basic. We have two symbols. Let's rewrite this one. So we have two of these, which is 10 plus 10. 1 plus 1 plus 1 is 23. Now, so that was from 159. Anything after 59? Now, if we look at this, notice how we switch these. And also, there's a space right here. You notice a space, but there's a space. Because from, actually, this should have been from 0 to 59, which is a base. What's the base number system here? If it's 0 to 59, how many numbers are there? 60. So this is like a base 60. So anything after 59, so 60 and above, we now have the grouping. So there's a space between there. So we have these two numbers here. Let me show you that. So we had and a space. And then we had the two tens. These are, again, reading left to right. So these were 10 plus 10. These were 1 plus 1. But now, since we had a space, this was times 60. Because this is now in the 60s. We have all these here we counted. Now we have two of these. So it's 2 times 60 is 120 plus 20. So we have 20, or 10 plus 10 is 20. It's in the ones column. This is in the 60s column. So these are the ones. These are the 60s. What's this one going to be? 60s. This is going to be the 60s squared. 60 times 60. This one's going to be 60 cubed. So those are taking big jumps. We had ones, tens, hundreds. Then went ones, 60s, 360s, 1080s, which is huge. Or,
So you put space in between each triangle or index.
that means it changes. And now this is one group of numbers. This is another set of numbers, right? So that means there's a space between each of these spaces.
So if you just have one triangle on range, 60.
Right. So this would be 60. If let's say we had here. So this would be 1 times 60 plus 10 plus 10, or 20 times 1. So it'd be 60 plus 20 is 80. Because remember, since this is a base 60 number, you can't go higher than 59. So that's what we have to do to make it. So here we have. That's the first one is the ones. This is the 60s. So this is 20 and 10 and 10 is 20. It's in the 60s column. And this is the 1 in the ones. So it's 20 times 60 plus 1 in the ones. This is 10 and 1, which is 11. It's in the 60 squared. So it's 11 times 60 times 60. This one is 11 times 60. This is 1 times 1. So you see, as if you have a space there, then you add another 60 to it. Ah, yes. Later, they introduced the double box arrow as a placeholder for missing positions. In other words, you know how we have 203. So we have 2 times 10 squared plus 3 times 10 to the 0. What about this middle column's missing numbers? There's nothing there. Remember, the 0 wasn't invented yet. The 0 was, we think of it as a basic type of number. But back then, how do you describe nothing? And then if you have nothing, why should I write it down? So that's where the whole, once they invented it, so there's 0 of these. So this is 2 times 100 plus 0 plus 3, which you add those together, you get 203. But if we're going to write this thing down, we had to have, what do you have in its place? And that's where they had those 2 pointy arrows up. So we know that. Why is that important? Because when you had a base system like this, these first set are times 1, because they're in the ones column. There's nothing in the 60s column, but we have 10s in the 60 times 60. So if this wasn't there, it made just look like a big space. So that's what, so yeah, there's, well, they didn't accept it, they didn't know what they did, but yeah, they represented the 0 first. But not in the way we understand it today. It just says there's the 0 they meant is this, there's nothing there. So the first one was what system? Egyptian system. And again, that was really mind bending because you have to memorize all those symbols along with the hieroglyphics. Babylonians was next. I mean, yeah, Babylonians were next, which they had a much more streamlined ones. Let's go to another part of the world, which is even a more misunderstood and unknown, the Mayans. The Aztecs and Mayans were so far ahead of Europe when it came to astronomy and mathematics and things like that, that we're just now figuring out how much they really knew. But they really didn't have a written language because nothing could really survive in the rainforests. You don't want to carry stones with you, so you could do that. You couldn't write down anything because anything you'd write with would wash away. So the communication system back then was pretty limited. So early numeric systems counting body parts, fingers, and if toes, you could do that. So the Mayans, they introduced the symbol for zero. We now have a number for zero. Unlike the Babylonians, because they introduced a number for zero, which is it because the Babylonians figured out the Mayans had this zero, or did they figure out themselves? Don't know. Because remember, back then people traveled by boat, especially if they were near the coast. If they were inland, they just walked around. So the seashell was a zero. The dot was a 1, and the horizontal line was a 5. The Mayan system is vertical. What does that mean? The Mayan system is vertical. So if I had that, what do the dots represent? And the line? So it's 2 plus 5 equals 7. What number would that be? Yeah, we have 3 plus 5 plus 5 plus 5, which is 18. You see the drawback of that system? Of only having 3 numbers vertically? Well, how would you write 472? Yeah, nobody's going to count. So they thought about that. Started grouping. If we take the 0 and put a number on top of it, we just now have a number bigger than 10. So this one here, we had 1, 2, 3, and 2 dots. So we had two 5s and a 3. But where did the 20 come from? Where did the 20 come from? It's, as I said earlier, is if we looked at how these things are structured, the 3 dots with 3 bars, that would get very cumbersome running any more than that. Or you have 4 dots and then three more lines or 4 more lines. But anything after that, so we had 4 dots and we have 3 lines. What number is that? Can I add any more dots on there? No, because remember, the dot was a 1, the line was a 5. So what's our base system? 5. Because from 0 to 4, we can use dots. So that means anything after that. So after that, we can use at maximum. Yeah, but this one just now throws it off. So that's why they have now a base 20 system, which is can we create a 10 with this? Yes, with 2 bars. Since 19 is the only one we can write comfortably, that's where this came in. this equaled 20. What would that equal? No, 40. It'd be 30. It would be 40. Yeah, 40. Because it's 120, 220s. See, so there's 1 plus a 20, and that's 19. So, and that's where they start saying, hey, the first 3 rows now is our base 20 system. The most we can go is 19. Again, now nobody knows why. Nobody knows why this occurs. Hold on. So you have, how ours, we have 10 to the 0, 10 to the first, 10 to the second, 10 to the third. Or the Babylonians, we had base 5. But what about this one? We had the ones, because anything to the power 0 is 1. So, do you think theirs was like this? No. For some reason, nobody knows why, they don't go clean like this. What they do is they drop down to 18. On the second column, the Mayans use 20 times 18 instead of 20 times 20 for the second column. Nobody knows why. So instead of placing 1, this is 20 to the power 0, 20 to the power 1. The Mayans used 1 for the first column. That's 20 to 0. This one's 20 to the first power. Instead of having 20 to the second power, they have 20 times 18. The only thing we can think about that it could be the explanation of that is because the Mayans had that calendar, the celestial calendar. How many days in the year were there? They used to think 360 days for the longest time, which it makes sense because we gain a couple of seconds every couple of years. If you think about it, the winter season, it used to be when I was a kid, we could bet during the Christmas break that it was going to be super cold. Now it doesn't get cold until when? But January, February, yeah. So you see how it's shifting. That's a matter of how the Earth rotates around the sun, how the Earth rotates itself, and a huge part is because of our clock system. Because our clocks are accurate, it's off by a few seconds. And that's why there are countries around the world that stop, that pretty much literally stop the clocks or adjust the clocks accordingly each year to get us back on schedule. But that our calendars keep on going. So because of that, our winter is now getting pushed back further and further and further. And so people say it's because the poles are changing. No, it's not the poles. It's because our counting system, our clock system's off. So anyway, that's what the theory is. So 20 times 18 is what? 360, which makes sense now. So now, after that, all of the 20s increase, but the 18 stays there. So it goes like this. It goes 20 to the power 0, which is 1. 20 to the power 1, which is 20. 20 to the first power times 18, which is 360. Now the 20s, so we have 20 to the second times 18, 20 to the third times 18. So you see, it's this third one for some reason, instead of 20 times 20, they went 20 times 18. 360. But again, I would say don't try to find them wrong with it, but let's figure out why. Because again, they were so far advanced with astrology and astronomy, that we are still learning things that they knew hundreds and hundreds, thousands of years ago. So that's the Mayan system. And we'll see also how they do bigger numbers. So as you see, the way they write these numbers, let's go back. I'm missing some examples. Oh, yeah, but here's what I think is erroneous about this. The seashell here is worth what? 0 is worth that. But now, how does it go from this to one dot on top of it? What is that? Making it 20.
I guess like looking at the face value system.
Yes.
That's the one space.
Yeah, it moves. Yes, because the first one was 20 to the zeros. There was no dot on top of there. So that's the first one. And then now they put a first dot. Then the second one they put a second dot. Yes, that's the only thing I can think about. Because you notice a lot of these they have pretty small numbers.
How do you describe when on the original?
This one, see, that's another question. That's a very good question. There is because if you just had two, this one's missing something. That one's missing something. Because you have two. It says here, if two horizontal bars are placed close together, the symbol represents 10. If the bars are spaced apart, it's 5 times 20. Yeah, like this one here. That's a good question there. Because how close do they mean they have to be close together? Only thing I can tell is they're longer, they're wider than these. Could that be it? So I have to look into that. I never thought about that before. I will look into that for you. Again, the Mayans, we're still discovering the villages in the Central and South America part that has been overgrown by tundra, by the forests. And we're just now discovering what they knew and making ourselves super humble. So, next one, the easiest one, I think. Well, actually, the second easiest. The easiest is the Hindu Arabic, which is our numbers. How many of y'all know how to count Roman numeral wise? How that goes? Okay, no, good, because I mean, I like talking about these because when I lived in Europe, I used to love to go to Italy and everywhere. I mean, all over Europe, even up the highest point in England, where the Romans went and conquered over there. You see all these Roman ruins, and you have Roman numerals everywhere. So the letter I represents one. The V is 5, X is 10, L is 50, Y is C 100 century. Like a centurion, the guard, he's in charge of 100 soldiers. Century is 100 years. D is 500. M for millennia is 1,000. Okay, now the way the Roman Whereas if you wanted to write the number 8, which one do you think is correct? Why?
It's the higher value, right?
Yes, that's exactly what it is. The higher, so you start off at the number 5, and then you add 3, and that gives us 8. In other words, if you put a smaller value in front of a bigger value, what does that mean? It's subtraction. Because now we're talking about the concept of subtraction. Formally, it's subtracting. What this means is I take one before 5. What's 1 before 5? 4. Or this is 10 before 100, which is 90. What is M? 1,000. What's C? V, and then 2. So 1,000 plus 100 plus 7. 5 and 2. 1107. Put that number into Roman numerals. Next, we have more room. let's think of how this number is put together. The same way you were taught when you first. So we have what? We have 1,000. We have 9 100s. We have 6 10s. And we have 4 1s. So what's 1,000? What symbol? There's only one of those. Yeah, but if we had 9 100s, how can that be written? How can 900 be written? Remember, in Roman numerals, you could never have more than 4 of a kind. In other words, like if I go from 1, 2, 3, 4, next one has to be a 5. Then 5 and 1, 5 and 2, and then X. Yes. This is 1,000. This is 100 before 1,000, which is 900. The next one, this number is 60.
Which the
Mm.
orbital, the four lines.
Okay, so what are the possibilities here? We could put, isn't that close to a 50? So it's a 50 and a 10. So this is, what's a 50? And a 10? So that means 50. And we do a 4. Because IV is the same thing, but it looks cleaner. IX is 9. It looks cleaner. So we can write this way. We have 1,954. If it was 56, it would be written like this. 64, yeah. Because here's a 50 plus 10. If it comes after, if the big ones come after, notice the size really goes down. If the smaller ones before, there was we had, what's that? But you wouldn't write it that way, really. You would write 900, which is CM. 90 is what? 10 before 100. And then 5. So this is 900, which is made up of CM, plus 90, which is 10 before 100, and then 5. So in this case, this is where the Romans really invented subtraction. And they used it that way too. No other ones do that. I mean, even in our number system, we don't do that. Yeah, they just the subtractive property and the multiplication properties. If they use the bar over the number, that means it's multiplied by that value, either whatever the thousands value is. So for example, 5 times 1,000 is 5,000, is the 5 with a bar over it. So it's whatever number you have, and you multiply that by 1,000. If you have two bars, so the bar on top means what? Yeah, so however many bars you have on top, that's how many thousands you have. So this is a CXI. So it's 111. Oh, no, but you notice how the bar only stops at CX, not over the I. I could see a lot of problems with this system. You're chiseling this, and all of a sudden, a little piece flicks off. Uh-oh. So that's the Roman numeral system. I see. So if a smaller number is in front of the, if small number is in front of a bigger number, it's subtraction. If it's after, it's addition. So IX would be 9, IV would be 4, XL, L is 50, X is 10, so it's 40. XC is 90, CD, D is 500, C is 100, so it's 400. So it's pretty cool how the Romans had all this stuff thought out. Again, it all had to do with marketing, with commerce, and how to tax people. So of course they came up with this, but they wanted to tax everybody for everything. They wanted to keep track of the population, the census. That's another census means what? It's it's a total count of everyone, and we do that every 10 years. And the Hindu Arabic system is what we use nowadays, and we know, hopefully remember from elementary school. So see how we went from thousands of years ago to today, how the number systems changed. Are all numbers written the same in the world today? There are some countries that use different numbers. They write numbers differently, but the concept's the same. It's base 10 because again, it all goes out to commerce. Any other questions? So again, I'm sorry I didn't have this one planned out. The reason I'm saying this is because Monday I won't be here, so we won't have class. Well, I'll let you know for sure. It all depends on when I come back from my conference. It's I'll try to come back Sunday, but if not, then I'll let you know for sure. So, other than that,